Hey guys, welcome back to another video, and in this one we're gonna try to make something like this really easily and really quickly in Blender. And let's get started. So to start off, I'm gonna start with a cube, and I'm gonna just have kind of a human besides it to kind of match its scale and make sure that it's 1.7 meters tall to kind of have an accurate physical scale of my building. I'm gonna scale the cube up and try to make it kind of a shape of a skyscraper, but I'm also gonna keep it like really low detail because it's gonna be really far away from the camera and it's gonna be instanced a lot. So the less detail we keep, the better. Just some extrusions, some bevels, and some basic intrusions, and that will be really it. Add a little bit of secondary pieces here and there, like this little extrusion here, and then I'm gonna try to make a kind of a window model which will give it that extra detail when it's viewed from far away. So that we're gonna model really quickly, and just that will be duplicated throughout the building. Just some basic blocky kind of shape to it. And we're going to keep it really low poly so that it doesn't really have a heavy effect on our system when we are trying to see the city and we're trying to render it. And so with these little windows which I've created, I'm just gonna place them in front of each bend and just finish off this building entirely. So it's kind of like a far away LOD model which you would use for a game or something. We're gonna use for this little project. At the end, we'll combine everything and just make sure that the center of this object is at the bottom, the ground, so that it's instanced properly. And finally, we're gonna give it some really basic materials. So I'm gonna select all the glass planes and give them a really basic glass material. I'm not gonna go over in detail in terms of the material yet. And then I'm gonna give it a kind of a concrete material to the building, and just a basic automatic UV projection will work. So, and then I'm gonna have kind of a 4 or 5 buildings, so that just like this, so that it's not too much repetitive. And that's it. I'm gonna name a collection out of it. I'm gonna name it buildings, and I'll use them for my scatter. Then now we're gonna try to build the city. So let's take a plane. I'm gonna head over to my geometry node editor. It's very important to apply the scale of this plane, and then we're gonna distribute some points on it. Have a really low density in the initial stages, because it's according to the scale, it's gonna have a lot of points even at a very low density, so it can become heavier. Then we're gonna instance our buildings onto it. So we're gonna take instance on points, and we're gonna have our collection buildings, and we're gonna separate children and reset children, and we're gonna check on pick instance, which will pick automatically random buildings from our collection. And again, we're gonna have a really low density. Now we have scattered our buildings onto our plane, but it doesn't have any kind of definite shape to the density of our buildings. It's just scattered throughout the plane. But first of all, let's have some kind of randomization in our scale and our rotation. So we're gonna have a random value node, and we're gonna set it to vector, and we're gonna have some minimum and maximum values for it. So we'll plug it into the scale, and that will give us some random scaling of our buildings really easily. So we're gonna have a really low value like 0.2 for our minimum, and kind of a higher value like 4 or 5 for our maximum value. So we have a ample amount of range for our scale. So we can have really huge buildings and we can have really small buildings. Then for the rotation, I'm gonna take a random value and set it to integer, and I'm gonna multiply it with a vector with only the z value of 1.571, which is actually 90 degrees converted into radians. And so we're gonna take the integer random value of z and plug it into the first input, while our second input is multiplying it with the 90 degrees radians value, which will give us the random rotations but only in the multiples of 90 degrees, and will avoid the really random rotations of buildings which would look weird. So we have a kind of a systematic rotation going on here, which is really cool. Next, we're gonna have a kind of a paintable attribute for our density and for our scale, so we can actually paint the density area of our buildings. So we're gonna do that by first of all having a group input for our density, and we're gonna multiply it with another group input where we're gonna set that value to be actually not a single value but our paintable density, right? So we're gonna plug our multiplied result into the density, and we're gonna go to the vertex groups, and we're gonna add a vertex group, and we're gonna name it something like density, of course, or you can name it whatever you like. But when you paint on it, it will give you that area where you want your buildings to appear, and so that will be really cool. And also we might want to see the plane on which we are working so that we can paint on it. So we're going to use a join geometry node for it. Now that we have the plane, we're gonna need to paint on it, but for that we need to subdivide it in a few times to have some vertices to paint over, and you can then easily paint on it. Now you notice nothing is happening on it even though we have painted an attribute, and that's because we actually haven't given it that particular attribute in the value. If we do that, you will notice that the buildings are only being appeared in the painted region, which is what we wanted. Now we kind of want to do the same with the scale. So first of all, we're gonna have the input group inputs for the minimum and maximum values for the scale, so that it's easier to change the scale values later on. And then we're gonna kind of multiply it with a multiply vector with a vector math node, and we're gonna use the combine xyz to have a group input converted into a vector. So, and that group input we will use for our paintable scale attribute. So we're gonna have another vertex group called scale, and we're gonna use that for our scale attribute input. And whenever you paint somewhere, it will paint the buildings to be larger in that area, so that you can basically sculpt your own skyline, which is really cool again. Right. Awesome. we have an attribute for density, and we also have an attribute for scale, which gives us a really creative freedom to define our own city and its skyline. Lastly, we want an ability to hide or unhide the underlying plane. So we're gonna have a group input, and we're gonna plug it into a switch, which will be, if true, it should read from the instance on points. Alright. Lastly, we want a control for seeing or hiding our underlying plane, which we can do that using a switch node. We'll connect the switch actual boolean to the group input and use false for instance on points output and true for join geometry output, and we'll connect the final output in the group output, and that will basically give us an ability to show or hide our plane. Right. And that's really it, guys. So we have our city, and you can basically use this node network on any plane or any geometry that you want, which will give you any sort of crazy looking city which you can think of. And that's really it, guys. It was a really simple setup, but it gives you a lot of creative freedom to have any sort of crazy looking city that you want. And that's it. So we'll meet again in another video, and I hope if you like this video, please give it a like and subscribe. And yes, we'll see you in the next one.